Dr. Ali Mesbah is an award-winning researcher and professor at UBC in Vancouver, so pretty close to here. He did his PhD at Delft University. His main research areas are software analysis and testing, and Ali has written many papers on software testing, one of which we read today, which finds that assertions are strongly correlated with test suite effectiveness. And so we're very interested and excited to be able to ask you some questions about your paper. Thank you for coming today for this. I'm also teaching testing next term, so I'm also interested maybe if there's time at the end where you can discuss about what kind of advice I can give the students about designing their test suites and test assertions. So I'm going to actually just go, I think, to the student questions because there's a lot of them. And I'll call the students to perhaps jump in and ask them. Suresh, are you there? Would you like to jump in with the first question?
Yes, sure. If it's okay, I'm gonna change my question if that's all right. Is it okay?
Oh, I don't know about that. I don't know. Ali, what do you think? Do you think you could change?
I don't know. I don't know. It depends on the question, right? No, sure. Go ahead.
Okay, thanks. My question was regard to security testing, and I was wondering that when we are writing unit tests or like different kind of tests for a software application, we know our requirements and we know the outcomes and we know what we are going to expect. But with regards to security testing, what do you think it's best how to design and implement unit tests for our application and assertions? Yeah.
Ooh, that's a tough question to start with. So
good job, sir.
Yeah. I mean, I always try to separate these two, right? So software testing is typically about functional testing, and security testing is about, I mean, I see it as a non-functional property of a system, right? It's not directly related to correctness. It's extremely important, maybe even more important than functionality testing, but it's a different beast, right? It's like security testing, you have to look at the system from a very different perspective, almost, you know, from a hacker's point of view, right? Whereas when you write a unit test case, you're just trying to kind of put yourself in the shoes of the developer who wrote the code and try to understand what the intention of the code was and try to kind of test the different, you know, aspects of that piece of code. So I don't know whether when you're writing unit test cases, you should also be concerned about security testing. Maybe it's a good idea if you are knowledgeable about security, because again, you need a different set of skills in order to realize that there might be a potential problem in your code and write test cases for it, right? I think that's, I mean, if you're knowledgeable in that security area, then that's great because you can write, you know, maybe extra guards in your unit test cases. Otherwise, I would say you would have to rely on experts because security testing is not easy. It's much more difficult than unit testing.
Yeah.
Thank you.
Good question, Suresh. I think that's a super interesting topic. Maybe we'll continue some discussion on that later in the term. Yeah. So I'll switch back to asking maybe Jonathan Bezo to ask a question. So there were a few questions that touched on the interplay between human and machine written assertions. So maybe we'll ask a couple of those. Jonathan, are you?
Yeah, I'm here.
There? Yeah, jump in, please.
So in your paper, you demonstrate the difference in effectiveness between human written and machine generated assertions. Do you think that this is still accurate considering how much machine learning has improved over the past 5 years since the paper was written?
Yes, I think it's still valid and true. And the reason is because we are not that far yet. I mean, there are some attempts in terms of generating test cases using machine learning. There are a few papers here and there. But the problem is that the most difficult aspect of test generation is the assertion part, as you probably know, right? And for the assertions to be generated, we need a good knowledge of the system we are testing. And the machines are not there yet, right? Even for us humans, it's difficult to come up with good assertions. Automatically generating these in the past, let's say 10, 15 years, we've developed tools that generate test assertions, but these test assertions, when you look at them, they're very generic, right? So For example, Randoop, the one that we talked about in the paper, it generates assertions for Java JUnit code, but the assertions are in the form of, if I create an object and I call equals on itself, it should return true, right? So an object should always be equal to itself. So those are the type of assertions that we can generate. These are very generic. You don't need any application knowledge or domain knowledge. With machine learning, we are trying to generate test cases, but again, I mean, source code is so, so difficult to make sense of and extract patterns from, that I think we will still are very far from being able to generate test assertions that are meaningful and actually really relevant to the code that is being tested. So do I believe our findings are still valid? I think so. I think if you were to take one of these tools that is generating test cases using machine learning and you compare that to a human written test cases, they would probably score really low still. So we haven't made a lot of advancements in terms of generating test assertions. We are excellent in generating test cases that give us coverage from many different angles. Like, statement coverage is easy, branch coverage, we can do even path coverage, right? With things like static analysis and even like, concurrent testing, symbolic execution, we can cover many different aspects of path coverage as well. But when it comes to test assertions, we don't know how to do it yet. So
Thank you.
I hope that's, yeah.
Yeah, thanks, Jonathan. Actually, Roshan also had a pretty similar question, so I'll maybe skip over that because I think it's still ongoing research, right, to figure that out. So Jory asks, are there certain classification of tests which automated tests are able to cover more? For example, null or not suggests.
Yeah, so again, I think this also is related to what I was just describing. So again, if the goal is for us to get coverage of the code that we're testing, we can achieve really high coverage just by generating test cases. And these test cases could be like the way that we generate them, we have advanced in that really drastically. We can generate test cases using like feedback from the previously generated test cases. We can use different metrics to kind of see whether we are going in the right direction. Yeah, so test automation for coverage is very advanced, right?
Yeah.
But again, for test assertions, we're not there yet. We don't know how to do it. Even for, I mean, if the assertion type is generic, like, assert that the object is not null, yeah, that's very easy to generate, right? But as soon as you need to know the value of a particular object and assert that to be equal to 25, we don't know, right? There are also tools like EvoSuite which mutate the application and they generate test cases that kill that mutant. So those are much more fine-grained assertions. And I think they're much better than just generic assertions, but it's still, are they the assertions that are generated in that way are still maybe far from an assertion that a human being would write, right?
Right.
Yeah.
Oh, that's a good segue to mutation testing. We have a few questions about that. I'll invite Tyler to jump in and ask his question.
Yeah, for sure. So my question, I really wanted to talk about mutation testing, which you just mentioned. So my understanding of mutation testing is that it sort of creates like a syntactic style of error, something that mimics a programmer's error. So I was wondering if you think that kind of testing is in any way capable of providing coverage for edge cases or bad inputs or covering for any kind of logical errors.
Right. So the goal of mutation testing is to assess how good your test cases are, right? So whether your test cases can detect potential bugs in the code, and the way mutation testing tools work is that people have thought about what are some of common mistakes that people make, which are very simple, right? Like you don't need complex bug patterns, something like off by one or typos in terms of writing equal to, and then instead of equal to you write larger than, right? So it's just like a very small glitch, very small type of bugs. And then they have like written mutation operators which are able to generate these types of small syntactic changes in the code, and that's basically how mutation testing tools work, right? So they generate, they pick a location in the code, they mutate it, they apply a very small syntactic change, and then they run the test cases to see whether they can detect it. Now, for any type of common small syntactic mechanical error type, you could actually write an operator, a mutation operator, right? Like most tools have a long list of mutation operators. Some of them are enabled by default. Other ones are more experimental. You can turn them on or turn them off. And yeah, so for things like off by one, there are already mutation operators in tools like PIT test. And also most of these tools allow you to write your own operators. So if there's something you think is really valuable to be mutated and tested, you can write your own mutation operator. So yeah, I don't know if that answers your question, but yeah. So mutation testing is actually, I mean, it's a relatively old concept in the testing literature, but it's actually making its way to industry. So I was really glad and surprised first, and then glad that I saw people are using it at Google. So they have a team actually started writing their own tool because it has to be scalable on their code size, and it's making its way into industry now after so many years, and that's I think that's wonderful.
Great, thank you, Tyler. I think that probably did a good job at answering your question, and actually you also answered the next one. Derek was also wondering about sort of the use of machine learning and mutation testing, and I think yeah, you touched on that very nicely. Changing tracks just a little bit and maybe looking towards future work, I'm going to jump to Dylan's question. Dylan, would you like to ask your question that you posed for today?
Yeah, for sure. So yeah, mine was more about future work. You say that programs written in Java may not be representative of programs written in other languages. So yeah, do you have a prediction as to if they do or not? I know this is probably like something that needs to be explored, but do you think the findings from your paper would translate?
Yeah, so that's a good question. So in research papers, we always have to be really careful in terms of what we claim, right? And the scope of our work, and especially with the empirical studies. I mean, Peggy knows more about this than me. So we always try to kind of say, you know, this is the finding these are the findings that come out of our study, but be careful not to apply these at large on any other system that you're seeing, right? So this is the scope of our study. It's really small in the space of all possibilities, right? All languages, all different, you know, types of systems. So that's one aspect, right? So we have to say this is only for Java, this is only for this type of systems that we've conducted our experiment on. But can you extrapolate this study into, like, for example, programs that are written in C++ or C#? I think you could, right? There's nothing in there that would say unit tests, because unit tests are written in a similar way for C# and C++, right? There's not much change there. And they also have test assertions. If you use a mutation, like a mutation testing that applies changes to C++, you could conduct the same study, right? And I personally believe that code coverage is not a good metric. So this is another discussion that we can have, right? So we've spent so much time on code coverage, like statement coverage, branch coverage. There are many tools that people use in industry, but now we've come to understand that code coverage actually is not that meaningful, right? You could have 100% code coverage without a single assertion that is doing nothing for you, right? It's just executing your code. It's not checking anything, right? So that's why we actually conducted this study, to kind of show the value and the role of test assertions. And these test assertions, you have them in any language, in any testing framework for any language. You take them away from any language that you're testing, and I think your test cases become useless, right? And you put more of them in there, and your test cases become more effective. So that's the way you can think of it, right? So yeah, so probably our findings would apply to other languages and other unit testing. I mean, let's just focus on unit testing, not other types of testing. Yeah, so it probably would apply the same in other languages. But again, we need to do, as scientists, we need to do experiments to actually show that empirically we would get the same results, of course.
Awesome, thank you.
I was wondering if Dave wanted to jump in with his question next.
So if test effectiveness is in correlation to assertion numbers and quality, then is there an upper bound to which the number of assertion and quality like does not increase the test effectiveness? As in, like, it doesn't matter how much the assertions and quality like it passes, it doesn't like change the code at all.
Okay, interesting. I think that's a good question. I think that there is a limit in terms of what you can assert for a particular method that you're testing, right? So if you have a method foo and it is taking two arguments and it's doing some calculations, I mean, how many different types of assertions can you do on that, right? That's the real question. In some test cases, so if you look at the paper, and there's a table in the beginning, I think it's table 2, it actually shows how many test assertions are there on average for different subjects. And we were surprised to see that if there's like a mean average max or something like that in there. If you look at the max, you see that some of them have like more than 100 assertions per test case, right? And so we were really surprised to see that. And initially I told Yucheng, my student, that this must be a mistake, right? So go and explore. So she went and looked at the actual test case that had this maximum of 100 something. And surprisingly, it actually did have so many assertions. So people sometimes write extreme, like they really go extreme in terms of writing assertions, but these are like outliers. On average, I think a test case has 1 or 2 assertions, not more than that, right? And that in most cases, that is enough, because you want to do something, like you want to call a method, get something from it, and then assert whether it's doing that correctly. And maybe you pass some other like edge cases or boundaries to the method, and then you get a return value and you assert on it again. Now, whether there is a upper boundary in terms of how useful the assertions can be, there probably is, depending on the complexity of your method, right? If you have a really complex method, you need more assertions. If your complexity is low, you don't need that many assertions. What that upper bound is, I don't know. We probably need more studies. So it's actually a good, this will be a nice research question, right? Like, is there a correlation between the complexity of your method and how many assertions you need in your test case for it to be effective, right?
Yeah, because I did think from the point of view of you, like a developer just wasting time trying to get like everything passed and everything, right? So that would be pointless and doesn't help the industry at all. So like I came from industry, that's why I thought, like, you know, what if there's like an upper bound that doesn't help you and just like wasting your time to try to get like the code back.
Right. Yeah. So I mean, based on what I've seen, I personally wouldn't worry too much about the upper bound. I would worry about whether we have enough assertions or not, right? I mean, if you have too many, there is no harm in it. If you have too few, then you might miss some potential bugs in the future, right? So that's also another way of looking at it.
Okay. Yeah, interesting. Yeah, thank you.
All right.
Thanks, Dave.
That was a great question. Thanks for that. Yeah.
Yeah, one of the questions I was going to ask you at the end is the students have to do an empirical study, design an empirical study, or do some kind of a replication for their project coming up. And I was going to ask if you had any suggestions, but it looks like there's a good suggestion, perhaps right
this
there.
One might be this one might be an interesting one, and who knows? Maybe there's a paper to be written here.
Yeah.
So, yeah.
Maybe you could help.
Definitely. Yeah, I'll be happy to if somebody's interested to
dig into this.
To start exploring, definitely.
Yeah.
I think it's an interesting question, yeah.
I'm using Zoom chat, everybody, by the way, to kind of say who's up next. I don't know if you've realized that, which is a new practice. We're just learning how to do this. Nimi, your question was sort of answered, but maybe you want to focus on the second part of it.
Yeah, I think it's sort of answered. My question was related to Dave's question. It was like, you have mentioned in your paper, there was a you have mentioned that the results show that the number of test cases in a test suite and the number of assertions in a test suite has kind of a linear relationship. So my question originally was like, do you think that there is a kind of a practice that people use constant number of assertions in a test case as a practice? But I think it's kind of like answered. And how do you like to describe it with like respect to the automatic test generation? Sorry, test case generation kind of like.
I'm not. So what is the second part of the question? I didn't get that part.
It's like, and how can you describe it with respect to the automatic test case generation?
You mean the correlation between test assertion and test size, test suite size? Yeah. Okay. So yeah. So if let's take the average, right? So for human written test cases, if the average is, let's say, 2 assertions per test case, then as more test cases you add to your test suite, the more test assertions you will get. So there's a linear correlation between these two, right? If you consider the averages. Now with test automation, test generation, it's kind of similar because these tools, they have predefined conditions to generate test cases, right? It's either one assertion per test case, or 4 assertions, or 5 assertions. These are usually like hard coded even, right? So they ask you how many assertions do you want for your test case? You say 5, and it generates 5 assertions per test case. So then again, if you plot that, you would get a linear correlation between the number of assertions that are generated and the number of test cases that you have, right? So test suite size, I just want to make sure that we are like everybody understands the test suite size in our paper and all the other papers is basically the number of test cases that you have in your test suite, right? It's not about like how many lines of code you have in terms of the size, actual, like when we talk about code size, we usually think about lines of code, right? How many lines of code you have. But in testing literature, code suite size is basically just the number of test cases that you have.
Okay, thank you.
Good, thank you. Shusha, I was wondering if you could maybe ask about the qualitative set of assertions. And this was also a question that Cassandra had. So I think your question will cover both.
Okay. Okay. I wanted to know your opinion that what are the reasons behind effectiveness variation in different assertion types? And will we get this answer easily by qualitative analysis of a set of assertions?
Yeah, so that's a good question. So when we wrote the paper and we submitted the paper to FSC, we had some indication in the subjects that we studied that there were some correlations in terms of effectiveness and types of assertions. In the paper, we say that we need more studies and more experimentation to kind of see why this is happening, right? Because we didn't know, we couldn't justify it. So then later on after the submission, we did a much more thorough study trying to understand and see whether there is actual correlation between these, because we only saw it in a few subjects. And then based on a lot of experimentation, we saw that we couldn't actually find real strong correlations between assertion types. Apart from, let's separate manual versus automated study. So that study is definite, like that's firm. But when you talk about assertion types in terms of, is this like an assert true, assert false, and then also asserting on the type of the let's say arguments, like is it an object, is it a string, is it a Boolean? There we couldn't find really strong correlations for larger subjects, right? When we consider like a larger set of subjects, we couldn't find any real correlations there. So yeah, so I can't really say much more than that there is really no strong correlation in terms of that assertion method or assertion argument types as far as I'm concerned. We couldn't justify that, and we couldn't find more evidence of it. Yeah.
Perfect. Thank you.
Great. Thank you, Shusha. For our last question, I'm just going to roll a couple into one as we're close to the end of our 30 minutes. Tomas had asked if a development team is inexperienced with using assertions, would it be better if they used computer-generated assertions until they gain the necessary experience? And I think that's quite an interesting question, and a bit sort of related to that. Zane was wondering, how should testing be taught to students? You know, is it looking, it seems that the current approach is mostly looking at code coverage, which you've already questioned. So maybe you have some insights on those questions. And
right.
Yeah.
So so the first one, if somebody is inexperienced, I don't believe that automated test assertions that are generated would help them. It probably will make them more confused than anything else. I think it's better to try to understand the method that the person is trying and try to kind of poke it from different angles. And then have somebody who's really experienced to do a code review and say, yeah, this is a good one, but maybe you want to think about this aspect as well and write that test case with these types of assertions. I think that's probably the most useful way of gaining knowledge in terms of how to do it. So that's one way of empirical, getting experience from co-developers. As far as teaching and learning in an academic setting, I personally believe it's best to expose students to testing as early as possible. So for example, Ali Mesbah, my own PhD advisor, he actually pushed software testing to the first year of their undergrad program. So when the students start learning to program, if they haven't done that before, they get exposed to testing right away. So that becomes part of their kind of mental picture of writing code. You don't write code and then later on think about testing. You write the test cases as you're writing the code. So that's something that I think is really, really important. And then how do you teach them software testing? Well, I mean, there are some fundamentals that can be taught, like what is software testing, what are challenges, what are some of the techniques that are helpful. And then also talking about, so what I do I'm teaching software analysis and testing right now, but it's a 4th year undergrad course. So what I try to emphasize, after the foundations are explored, I also talk about a little bit about the literature and some of the findings of these empirical studies. Like, for example, we cannot rely on coverage so much, right? So we have to be careful there. It's useful to tell us what has not been covered, but when it's covered, there isn't much information there that we can use, right? And then, I make them think about other ways of, writing test cases and thinking about that. And also not relying too much on tools, right? Like test generation is fine and nice, but we're still taking baby steps here, right? So we shouldn't rely too much on them. Yeah, hope that's useful.
Very useful. Yeah, thank you very much, Ali, for joining us for a half an hour today. And
yeah, it was great to be here. Thank you so much for your great questions, and I enjoyed them very much.
Yeah, thank you very much. Thank you.